Welcome back. In the last session, we have discussed about computational regression equations on the basis of assumed mean. Let us discuss other cases that comes under the same heading. Next one, computation of regression equations when deviations are taken, and within that, if the deviations are taken from actual mean. We have learned about computation of finding out deviation on the basis of assumed mean and actual mean in case of correlation, and previously we have discussed about finding out deviation on the basis of assumed mean. And I hope you all know how to find deviation and what is the meaning of assumed mean as well as actual mean. And remember, for assumed mean and actual mean, the equations are different. Just like the methods which we have learned in correlation, the same pattern of computation is followed in case of regression also. For computation of assumed mean, there is one equation, and for actual mean, there is another equation. Let us discuss about that part. So, regarding finding out deviation, for finding deviation, dx equal to x minus mean, and for dy equal to y minus mean. See, here deviation is based on the actual mean, the mean which you found from x as well as y. In the previous case, you have taken a number which is closer to the mean, but you won't take the actual mean, because in case of assumed mean, you will be taking a value nearer to the mean. That is why it is known as assumed mean. So, since the dx and dy is computed on the basis of actual mean, your dx, sigma dx and sigma dy will always be 0. Since these two variables, that is sigma dx and dy, are 0, the equation can be changed to this form, where dyx is can be computed by sigma dx dy divided by sigma dx square, and bxy can be computed by using the equation sigma dx dy divided by dy square. So these are the equations for finding byx and bxy in case of finding out regression equation when deviations are taken from actual mean. It's quite easy. So let us try with an example. From the following details obtained from two regression equations, sales is given, purchase is given. So let us note down the details regarding sales and purchases in a table. And remember, since there are no information regarding which one is x or which one is y, we can assume that the first details, that is details relating to sales, can be considered as x, and sales details regarding purchases can be considered as y. So when let us substitute these details in a table. So from here on, we will deal with values regarding sales and purchases in association with the tables. Here x determines the details regarding sales, and y depicts the details regarding purchases, and already found the total of x and y. I hope you know why we have taken the total of x and y, because for regression, whether it is an assumed mean case or an actual mean case or whatever the case may be, you need to identify the mean of x as well as mean of y. So mean of x is given, mean equal to sigma x by n. Here total of x is 900 divided by number of items 10, you will get 90. And sigma y is mean of y, sigma y by n. Here y total is 700, 700 divided by 10, you will get 70. Once you found out the means of x as well as y, next you need to find the dx. Here dx is computed on the basis of actual mean, because you have already found the mean of x and y. So dx is x minus mean of x. Here it is 90. So from each value you need to deduct 91 minus 90, 97 minus 90. Likewise, you need to find the dx. I hope you know how to find the dx. And once you found dx, if you take the total, see, you get 0. Here the total of dx as well as dy the totals will be 0. That is why we are using this equation when the regression is computed on the basis of deviations from actual mean. Once you found dx and dy, next you need to find dx square, that is square of each individual values in dx. Take the total, move on to next one, dy square, square of each individual item in the dy column. Take the total, and finally dx dy. That is just the multiplication of the items in the dx column and the items in the dy column. Take the total. Once you found all these variables, next the equation for finding whether it is a y on x or x on y. First of all, you need to find the regression coefficients, and that is byx and bxy. Byx equation is sigma dx dy divided by sigma dx square. Sigma dx dy, here it is equal 3900 divided by sigma dx square is 6360. You will get 0.61. Likewise, you need to do the same for the next one, bxy, because in this question you are asked to find two regression equations. Since two regression equations has to be found out, you need to find byx as well as bxy. So bxy is sigma dx divided by sigma dy square. Sigma dx dy is 3900 divided by sigma dy square is 2868. You will get 1.36. Once you found the regression coefficients, that is byx and bxy, next you need to substitute these in the equation. So byx is related to y on x and bxy is related to x on y. Y on x is equation is y minus mean of y equal to byx into x minus mean of x. Similarly, x on y equation is x minus mean of x equal to bxy into y minus mean of y. So let us go simultaneously. First of all, we will deal with y on x. Here the y, we don't know value of y. Usually y will be the unknown variable. We are using that as a computational equation. So y, let it be like this, y minus mean of y is already found 70 equal to byx is already found 0.61 into x, we don't know, x minus mean of x is 90. Similarly, in case of x on y, here x we don't know, x minus mean of x is 90, so x minus 90 equal to bxy, we already found 1.3x into y minus y mean is 70, see 70. And next step is you need to shift all the values to the right hand side, and you need to shift the only variable that remains independent to the left hand side. Here y will be the only variable that comes to the left side of the equation. Here x is the only variable that comes to the left of the equation. So it will be like this, y equal to 0.61x minus 54.9 plus 70, x equal to 1.36 minus 95.2 plus 90. Finally, equation for y or y on x is 0.61x plus 15.1 and x equal to 1.36x minus 5.2. So this is how you have to deal with the computation of regression when the deviations are taken from actual mean. Find out the mean, use the same mean for finding dx and dy, and thus the same. The only change is that for computing byx and bxy, there are two separate equations. Use that equations. Once you develop the two equations, or once you developed or framed two equations, that is when equation y equal to this one and x equal to this one, your answer is complete. Sometimes in the question they might ask, like, if the value of x is given, what is the value of y? Or if the value of y is given, what is the value of x? So accordingly you have to use the equations depending upon the nature of the question. So this is how you have to deal with a case where you need to find the regression when the deviations are taken from actual. Let us move on to next one. A relation between correlation coefficient and regression coefficient. Till now we have learned about what is meant by regression, what is meant by correlation, what is the equation for finding correlation, and how a regression case can be dealt So today we will learn the relationship between correlation and regression. The regression coefficient of byx and bxy is related with correlation in such a way that the byx can be computed by using this equation where r means correlation coefficient, r is related to the standard deviation of y divided by standard deviation of x. Remember, in case of byx, here y is first one followed by x, so it will be r into standard deviation of y, see, first one, divided by x, standard deviation of x, second one. So here byx means y on x, where y is unknown and x is known. That is a concept. So whenever you come across a question where correlation coefficient or standard deviation is given and you are asked to find the regression coefficient, this equation has to be used. So this is a case of byx, whereas bxy equal to same situation, r into standard deviation of, see here it is bxy, first one is x, so standard deviation of x divided by standard deviation of y. So this is the equation for finding regression coefficient when correlation and standard deviation is given. Let us deal a question relating to the same category. From the following results, estimate the yield of crops when the rainfall is 22 centimeters and the rainfall when yield is 600 kilograms. Understand the question very wisely. From the following results, estimate yield of crops. You need to find yield when rainfall is 22. That is one part of the question. Next one, you need to find the rainfall when yield is 600 kg. That is second question. Simple meaning means you need to find two equations and find out the value of rainfall and yield in two different questions. That is the concept of the question. You have to be very cautious while dealing with the cases that comes under correlation as well as regression. Understand the cases very wisely. So let us pinpoint the details given. Y and x is given, yield is represented by y, rainfall is represented by x. The mean of y and x is already given. Standard deviation is also given. So correlation coefficient in between yield and rainfall is also given. So whenever you come across a question like this where mean, standard deviation or correlation coefficient is given, surely you have to follow this method. Sometimes you will come across a question where you will get a details relating to a correlation pattern, and in that question you may be asked to find, first of all you need to find correlation, after that mean have to be found, standard deviation has to be found, and finally you need to find regression equation. Usually that will come under the category of essay question, but always prepare to face the worst. That kind of question can also be asked. We have to expect any type of questions. Okay, come back to it. So here you are asked to find yield of crop when rainfall is given, and second one, you need to find rainfall when yield is given. Such a question comes usually in case of regression. So first of all, you need these two equations because here the question is asked in two different types. One is given, another is not given, and another is given, one is not given, likewise. So first of all, y on x, y minus y mean equal to byx into x minus x mean. Similarly, x on y, x minus mean equal to bxy into y minus y mean. So the equation for finding correlation coefficient, byx equal to r into standard deviation of y divided by standard deviation of x. Equation is this one. R is already given 0.52 into standard deviation of y is 36.8 divided by standard deviation of x is 4.6. You will get 4.16. Similarly, you have to do the same in case of bxy. Equation is r into standard deviation of x divided by standard deviation of y. R is given 0.52 into standard deviation of x is 4.6 divided by standard deviation of y is 36.8. You will get 0.065. Once you found byx and bxy, so just substitute these details in this equation. Y minus y mean is already given 508.4 equal to byx is already found 4.16 into x minus mean of x is 26.7. Similarly, in here also x minus mean of x is 26.7 equal bxy is 0.065 into y minus mean of y is 508.4. So by solving these two equations, you will develop two set of equation where y equal to 4.16x plus 397.328 and x equal to 0.065y minus 6.346. Once you have developed these two regression equations, you have to find the values of these two questions, where first one is when the rainfall is 22, find out the yield. So when y, we don't know, here y yield is considered as y and rainfall is considered as x. So when x is, rainfall is 22, so x is 22, you need to find yield. So y we don't know, so we will use this equation because this equation is for finding out the value of y. You will get 4.16 into x is 22 plus 397.328 equal to 488.84 kg. So you found the yield when the rainfall was 22. Similarly, in here second part is you need to find the rainfall when the yield is 600. So rainfall is considered as x and yield is considered as y. So we don't know x, we know the value of y. So this equation is used because this equation is for finding the value of x. So x equal to 0.065 into y is 600 minus 6.346, you will get 32.654 centimeter. So this is how you need to find the regression coefficient or regression value on the base of correlation coefficient, which includes mean as well as the use of standard deviation. So be familiar with all these steps. Not only the regression equation pattern, but also familiar with finding out the value of correlation and also finding out the standard deviation of x as well as y. So just go through all these cases. We will discuss about the further cases in the next session. If you have any queries, please let me know.